Hello friends, MoNaCo here in our 8th lecture on acids and bases. We're covering neutralization and titration reactions in this lesson. So you'll be able to write and balance acid-base neutralization reaction. We did a little of that at the beginning of the unit. We're also going to use that titration equation and calculation to determine the unknown volume or concentration in an acid or base neutralization reaction. Since acids and bases neutralize, we can use that idea to neutralize an unknown concentration with a known concentration and do some back calculation to figure out how concentrated the unknown was. All because the neutralization reaction produced salt and water, which have a pH of 7. And so we can use pH indicators in this reaction to calculate backwards what the unknown concentration was. So neutral is neither acidic nor basic. Water and a salt are always produced when we have a neutralization of an acid and a base. So acid and base, we always get H2O and a salt. Now salts do not have OHs in them and they do not have H's in them, so they are neutral themselves. Antacid works on your tummy when you have an upset stomach or heartburn because your acid's kicking up in your stomach and acid is base. So it neutralizes the acid so the burn stops. You might still have the acid production problem, go see your doctor, but the burn feels and stops for the time being. Now, this is how they look. The acid, H plus donor, base, OH negative donor, they come together to make water and a salt. H plus from the acid and the OH negative from the base combine. The anion from the acid and the cation from the base also combine to produce a salt, which was this second part here. These two coming together to make that species right there. Okay, draw those together. Anyways, neutralization reactions are always a double replacement reaction. So there's that double replacement reaction happening again. Even though it's acids and bases, they're always double replacements. Positive and negative charges must be balanced as well. Using the crisscross rule helps us figure all that business out. The net ionic equation for a neutralization reaction. So if you ignore the spectator ions, that's what we call these guys, the positive and negative extras, the spectator ions. If we ignore those, then we've got H plus OH negative making H2O. That is the neutralization net ionic equation. Period. End of story. Moving on. So complete a couple of these. We put the H with the OH and the cation and the anion together itself. So let's look at our brackets. So we got our H there. We'll find the OH that it goes with there. So we got H2O because that's HOH. We did that in the first couple videos. And then we look at the other stuff. We got K and Br. These two goes together. K comes first because it's the positive ion. Br comes second because it's the negative ion. Let's look at the next one. OH. That goes with an H. So that'll make H2O. H2O. And then the other stuff comes together. Na with the C2H3O2. That's the acetate. So Na C2H3O2. Sodium acetate. That would be the salt that was produced. So let's look at this last one. I'm going to skip 3. You do. I just can give a couple hints on number 4. Look at how many H's do we have? How many OH's do we have? Okay, I got 2 OH's and 2 H's, so I'm going to make 2 H2O's and something else. Okay, so for 3 and 4, I want to see you finish up these 3 lines when I check your homework. Don't leave them blank, you won't get credit. Do we always get a completely neutral solution? Strong acid plus a strong base. Typically, we get a neutral. Now, the pH of a neutral solution is going to be 7. A strong acid plus a weak base. So it's mostly acidic, weakly basic. Well, we're going to get mostly acidic left over because it was strong plus a weak. So the pH is going to be less than 7. Less than 7. Weak acid plus a strong base. Super strong base, weak acid. It's going to be basic when we're all done. So greater than 7. Okay. There we are. So let's check out some titrations. Titration is the technique that we use in the laboratory to calculate the concentration molarity of an unknown solution of acid or base. Okay, so this is a titration. It's an actual laboratory procedure that you will be doing for this unit's lab. Acid of the known quantity or unknown quality is reacted at a carefully measured amount of a base of known quantity to get the neutralization to occur. We only want to just barely neutralize these things so we can measure the concentrations. In all neutralization reactions, there must be a 1-to-1 ratio between the moles of H plus and the moles of OH negative. So in a titration, whenever H plus equals OH negative, we've got the equivalence point of that particular reaction. This is when the titration is complete. So we call the equivalent point is when the titration is complete. The end point of titration is when the solution changes color permanently. So when we've got our indicator in there, it starts to change color. We've kind of hit the equivalent point. When it stops changing color and stays like pink, yellow, blue, whatever color it ends up being, that's when we've really hit our end point of the titration. Titrations look like this apparatus. We're going to do this in class. I would encourage you to check out the animations there. Those are nice to look at in your own time. We're actually going to do a lab on this, so you're going to get some good practice there. There's a titration calculation from formula table T, and it goes MAVA equals MBVB. MA, molarity of the acid, VA, volume of acid, MB, molarity of base, VB, volume of base. So it's basically saying that when all is said and done, the molarity and the volume of the acid is going to equal the molarity and volume of the base, because that's how you get a neutralization reaction. They have to be equal to neutral out at pH 7. You're going to deal with titration or neutralization word problems. That's when you use that calculation. And make sure that all the units are in agreement when plugging into the formula. This is a plug and chug type of thing, but if you're trying to convert like liters to milliliters and you forget to do your unit conversion first, the answer is going to come out funky and you're going to get stressed out. These are the type of sample problems I want to run through. What's the concentration of a solution of HI if 0.3 liters is neutralized by 0.6 liters of a 0.2 molar solution of KOH? First thing you always do when we're doing word problems, write out the master equation. Don't be lazy. This is how it's done. Then you find the variables, identify or define the variables, and then you plug and chug. Don't go straight to the plug and chug because you might make a mistake. So we want to find MA, we want to find MB, we want to find VA, and we want to find VB in the problem. So the molarity of the A is for acid, and it says what is the concentration of a solution of HI? HI, there's our acid. So we don't know the concentration. That'll be our X. Molarity of the base. KOH is a base. 0.2 molarity is the answer, so 0.2. Volume of acid. Well, it says if 0.3 liters is neutralized by, so volume of acid is 0.3 liters, and the volume of the base right there, 0.6 liters, 0.6 liters. So we're finding out the X molarity, the M's for the units of molarity, and the L's for units of liters. So then we just plug and chug, MA, VA, MB, VB. So we got X times 0.3 equals MB 0.2 times 0.6. Well, that's a pretty straightforward way to calculate that. X in this scenario, calculating your answer, so let's see, 0.2 times 0.6 divided by 0.3, 0.4. 0.44. And that would be our answer. So, 3 steps. 1, equation. 2, define the variables. 3, plug and chug. Okay, plug in and chug in. I'll help you with the first 2 steps, 1, 2, put the equation and define the variables for the sample problem 2. And sample problem 3, I'm going to have you do all on your own. Sample problem 2. What's the concentration of hydrochloric acid solution if 50 mils of a 0.250 molar solution of KOH are needed to neutralize 20 mils of the HCl solution of unknown concentration? So The way these are worded can be tricky, so always write MAVA equals MBVB, and then you start looking for the stuff. MA, molarity of the acid. Molarity of the acid is what is the concentration of a hydrochloric acid solution? Well, that means molarity is unknown. It's asking me what the concentration is, so that's got to be the unknown. Volume of acid. So 50 mils of a 0.250 molar solution are needed to neutralize 20 mils of the HCl. So 20 mils of the HCl is what we're working with here. MB, molarity of the base. Well, there's a molarity number, concentration, and there's the base right there. So 0.250, capital M for molar. And the volume of the base. 50 mils of that solution was neutralized, so we got 50.0 mils there. So we have done 1, we wrote our equation. 2, we defined our variables. 3, chug is U. You do it. Show me that you have the math skills there. Sample problem 3. It's a titration. Particular acid has H plus concentration, 0.1 molar, and volume 100 mils. What volume of a base with a half molar concentration will be required to neutralize the reaction? Same 3 steps. Equation, MAVA equals MBVB. I want to see you define all the variables and calculate that problem. Okay. If you need help in class, bring it in. We'll work on it together, but that is on you to do. 4th one, why did I double star this one? You have 50 mils of 1 molar H2SO4 solution. What volume of a half molar NaOH should be required to neutralize the acid? Remember, diprotic acids yield 2 ions in solution. So there's your hint. What's the molarity of H2SO4? So MAVA equals MBVB. Molarity of our acid. You might want to say 1.0 molar, but this acid comes with 2 hydrogens, so I want you for your molarity of your acid to say 2.0 molar, because that's really how many acid ions would be produced when that stuff dissociates in water. Everything else follows like the standard 3 steps. Equation, defining variables, plug and chug. Okay, so again, I want to see your results for this to get full credit. At this point, you should be able to tell me that the products of a neutralization are salt and water. And you should be at least able to set up the titration calculation to find the unknown variables. Okay? Calculating it, maybe you need some assistance in class. That's what I'm here for. And there's lots of practice on this material. So 7, 8, 9, and 10 are all molarity calculations. And we are going to be doing a lab on this unit to see the color changes of pH indicators as you do a neutralization reaction. Do their thing. So thanks for watching. Have a good one.